Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, there will be 16 practice test questions that should prepare you for the mathematics knowledge subtest of both the Armed Services Vocational Aptitude Battery, that is the ASVAB, as well as the pre-screening Internet Delivered Computer Adaptive Test, that is the PiCAT. As always, you'll want to pause the video after I read a question, attempt to work out the question on your own, and then resume playing the video to check your solution in order to get the most out of this video. And of course, you're not permitted to use a reference sheet or a calculator on the actual ASVAB or PiCAT. So as you work your way through these questions, try not to use any of those resources. Since this is going to be a long video, I also want to mention this in the beginning. If you want to help my channel out, please consider subscribing to it. The more people subscribe to this channel, the easier it will be for other people to find my free content and prepare for the ASVAB and PiCAT without spending any money whatsoever. Since I would consider these questions fairly difficult, here's how you want to grade your performance on it. You want to answer 65% or more of these questions correctly. Again, these questions are difficult. Some of you will see these questions for the first time. And in light of that, don't grade yourself too harshly. If you get about a 65 or a 70%, you should do pretty well on the ASVAB by studying for just a week or two. Of course, if you need more help with any of these questions in today's video, just keep in mind that in the description of this video, I'll have timestamps associated with each question. Next to the timestamp will be the topic that the question's testing, as well as a link to a video where I discuss that topic in greater detail. So with all that finally being said, let's go ahead and get started with this practice test. All right, so number one says, what is the average of 1/3, 1/9, and 1/6? So for this one, you have to know the formula to find the average, and that's this. M refers to mean or average, is equal to the sum of the data points that you're given divided by the number of data points that there are. So that looks like this. We're going to take the sum of 1/3, 1/9, and 1/6 like this. 1/3 plus 1/9 plus 1/6. And we're going to divide that by the number of data points there are. Well, clearly there are 1, 2, 3 data points. And the difficult part about this problem is simplifying what's in the numerator here. As you can see, we're adding these three fractions together. In order to add fractions, they all have to have the same denominator. So let me go ahead and pull this off to the side. We have 1/3 plus 1/9 plus 1/6. So to add fractions, they all have to have the same denominators. In this case, we have denominator of 3, 9, and 6. So our goal here is to find a common denominator between those three. You should know that 3, 9, and 6 all go into 18. And in light of that, we're going to have to rewrite all these fractions such that they have a common denominator of 18. To write 3 as 18, we would have to multiply it by 6. 6 times 3, of course, is 18. And we're also going to have to do that to its numerator. 6 times 1 is 6. To write 9 as 18, we would have to multiply it by 2, given that 9 times 2 is 18. We're also going to have to do that to its numerator. 2 times 1 is 2. And to write 6 as 18, we're going to have to multiply it by 3. 6 times 3, of course, is 18. And we also have to do that to its numerator. 1 times 3 is 3. Now that these all have the same denominators, we can go ahead and add them like this. This becomes 18, 6 plus 2 plus 3. And that should be pretty easy to do in your mind. 6 plus 2 is 8. 8 plus 3 is 8, 9, 10, 11. So this is 11 over 18. So let's go ahead and plug that back into the mean formula over here. We have 11 over 18 divided by 3. Now at some point, or at this point, some of you might get stuck as to how to proceed. That said, you should realize that you can write the whole number 3 as a fraction by placing it over 1. We have 11 over 18 divided by 3 over 1. And whenever you have two fractions divided by each other, that's going to prompt you to use the algorithm keep, change, flip. This keep refers to this fraction in the numerator. You're going to keep that as is. So this is going to become 11 over 18. C, or change, refers to this fraction bar. You're going to change it from a fraction bar to multiplication. And flip refers to this fraction in the denominator. Instead of being 3 over 1, you're going to rewrite it such that it's flipped, notably as 1 over 3. And now when you multiply fractions, you just multiply straight across. Of course, this becomes 11 times 1 over 18 times 3. 11 times 1 is 11. 18 times 3, if you can't do that in your head, you're more than welcome to do it off to the side. I know when I took the test, I did a lot of simple math off to the side so as not to make any mistakes. So we have 18 times 3, if my pen will let me write it. Uh, 3 times 8 is 24, so bring down a 4, carry a 2. 3 times 1 is 3, plus 2 is 5. So this becomes 11 over 54, which we can see is answer choice A. In other words, the average of 1/3, 1/9, and 1/6 is 11 over 54. And I'm going to say this, I included a lot of fractions in this practice test. You will see fractions and decimals on the actual ASVAB and PiCAT, so make sure you can add, subtract, multiply, and divide fractions. All right, so number 2 says, what are the factors of 2x squared plus 8x plus 3x plus 12? So you may have noticed that in every single one of my practice test videos for the mathematics knowledge subtest, I include questions about factoring. You absolutely have to know how to factor for the ASVAB in PiCAT. So let's take a closer look at what they're asking us to factor here. We have 2x squared plus 8x plus 3x plus 12. Now, whenever you're asked to factor something that has 4 or more terms, and we have 4 terms in this case, that should be a clue that you might be able to factor that by a method called grouping. And when I think about factoring by grouping, I think about splitting my expression in half, and I want to try to factor these two parts of this expression separately. So let's focus in on this 2x squared plus 8x. What can we factor from that? Well, we can factor out a 2x, and that will leave us with x plus 4 in parentheses. Now, the key here is to factor out something from this next part of your expression such that you get the same thing in parentheses. In other words, we want to factor something from 3x plus 12 such that we get x plus 4 in parentheses. That's actually pretty easy to do. If we factor out a 3, that leaves us with x plus 4 in parentheses. Now you write your answer like this. You combine these two into a set of parentheses, so it's going to be 2x plus 3, and then we just drop down one of these x plus 4s that are repeated. So our answer is 2x plus 3, x plus 4, and we could also write it like this, x plus 4, 2x plus 3. Let's see where that's at. X plus 4, 2x plus 3. Of course, that is answer choice C. All right, so this is factoring by grouping. Sometimes you have to do that for the ASVAB. Sometimes the factoring question's pretty straightforward, but regardless, you have to know different factoring techniques for the test. Of course, you could have went through all these answer choices and expanded them out to see which one matches this expression right here, but that would be more time consuming. All right, so my recommendation is learn factoring techniques if you don't know them already. All right, so number 3 says, what is the area of a parallelogram if its base is x minus 2 and its height is x plus 4? So if you look closely on my reference sheet, which you can download for free from my website, asvabapp.com, you'll see that the formula to find the area of a parallelogram is simply base times height. And in this case, the problem gave us both the base and height of this parallelogram. Notably, it said its base, or b, is x minus 2, and its height, or h, is x plus 4. So with those two things identified, all we have to do is plug them into this equation. We know b is x minus 2, so let's plug that in accordingly. We know h is x plus 4, so we'll plug that in accordingly. And unfortunately, if we look at our answer choices, we can see that this isn't there. And in light of that, that should prompt you to expand this using the distributive property. Notably, you're going to take this first term, you're going to multiply it here and here. Then you're going to take this second term, multiply it here and here. So let's go ahead and do that. X times x is x squared. X times 4 is 4x. Negative 2 times x is negative 2x. Negative 2 times 4 is negative 8. Let's go ahead and simplify this. Since 4x and negative 2x are like terms, we can combine those to be plus 2x minus 8. All right, so that's our answer. I write these answers very close to each other because I don't want people to guess. So you have to take your time and look through these to find the right one. And we can see that that is answer choice C. All right, so number 4 says simplify the expression. We have x squared minus x minus 12 over x squared minus 4x minus 45 divided by x squared plus x minus 12 over x squared minus 5x minus 36. In case you're watching this video on a mobile device, I'll go ahead and copy this down off to the side here. We have x squared minus x minus 12 over x squared minus 4x minus 45. Of course, that's divided by x squared plus x minus 12 over x squared minus 5x minus 36. All right, so at this point, some of you might be stuck, which is perfectly fine. Once you see how to solve this one, uh, this is going to be a very easy question in the event you see it on the PiCAT or ASVAB. The way you want to think about this problem is like this. You want to treat this like one fraction and this like another fraction. So we're dividing two fractions here. And as we've seen in this video already, when you divide two fractions, you follow the algorithm keep, change, flip. And that's no different for this. We're going to keep this fraction on the left-hand side of the division sign the same. So let's just copy that down as is. We have x squared minus x minus 12 divided by x squared minus 4x minus 45. C, of course, refers to change. So we're going to change from division to multiplication here. And then this flip refers to the second fraction. And of course, it means to flip it. So we're actually going to have x squared minus 5x minus 36 in our numerator and x squared plus x minus 12 in our denominator. All right, so now you should know that when you multiply two fractions, you multiply straight across. But before doing that, we should recognize that all of these are quadratic equations. And typically, if quadratic equations are factorable, they look like this. So let's go ahead and try to factor all of these so we can simplify this expression as quickly as possible. So let's start right here. Let's try to factor x squared minus x minus 12. All right, so we're looking for two numbers that multiply to negative 12 and add to negative 1. Again, there's an imaginary 1 here. You should know that's going to be minus 4 and plus 3. Negative 4 times positive 3 is negative 12. Negative 4 plus 3 is negative 1. All right, so we factored that one. Let's go ahead and factor what's in the denominator here, if my pen will let me write it. We have x squared minus 4x minus 45. We're trying to find two numbers that multiply to negative 45, but add to negative 4. And of course, that's going to be negative 9 and plus 5. Negative 9 times positive 5 is negative 45. Negative 9 plus 5 is negative 4. So we factored that one. Let's go ahead and factor this now. Again, it's going to look like this if we can factor it. And we're looking for two numbers that multiply to negative 36, but add to negative 5. You should know that's going to be negative 9 and positive 4. Negative 9 times positive 4 is negative 36. And negative 9 plus 4 is negative 5. All right, one more of these to factor. And as I said, you can't escape factoring on the ASVAB, so this is great practice for that. This is like 4 factoring questions in one. So let's go ahead and factor this. We're looking for two numbers that multiply to negative 12, but add to positive 1. Again, there's an imaginary 1 here. That should be pretty easy to figure out. That's going to be plus 4 and minus 3. All right, so again, 4 times negative 3 is negative 12. 4 minus 3 is positive 1. All right, so now we're just multiplying two big fractions. So we're just going to multiply straight across as we normally would when we multiply fractions. That's going to look like this. It's going to become one very big fraction. It's going to become x minus 4, x plus 3. Of course, we're just multiplying straight across. So we're going to multiply these two by these two. So that's going to be x minus 9 over x plus 4. And we're going to do the same thing in the denominator. We're multiplying these two by these two. So that becomes x minus 9, x plus, my pen is starting to freak out here, times x plus 4, x minus 3. All right. And as you can see, that's not one of our answer choices. So there must be a way that we can simplify this expression. And as a matter of fact, there is. We can cross out corresponding terms in our numerator and denominator. So I can cross out this x minus 9 and this x minus 9. I can cross out this x plus 4 and this x plus 4. And that is all I can cross out. So that leaves me with this x minus 4. I don't know why my pen's not letting me write curves anymore. X minus 4, x plus 3 in our numerator over x plus 5, x minus 3 in our denominator. So that is our answer. And what would you know? That is, in fact, answer choice D. All right, so that is that one. All right, so as you can see, number 5 says subtract 5x squared minus 2x minus 10 from the sum of 5x squared minus 2x plus 9 and 5x squared minus 4x plus 5. So the first thing I want to point out is that this, and that are called polynomials. And in this video, we've already multiplied polynomials, but in this case, it's pretty obvious that we're going to be adding and subtracting polynomials. More specifically, it tells us to sum these two polynomials, which we'll go ahead and do. This becomes 5x squared minus 2x plus 9. And when you sum two polynomials, all you do is line them up together and combine like terms. So this is plus 5x squared minus 4x plus 5. And to combine like terms, you first have to identify like terms, of course. Like terms have the same letter variables raised to the same power. So in 5x squared, we have the letter variable x raised to the second power. Its corresponding like term is going to have x raised to the second power. And we can see that that is right there. 5x squared plus 5x squared is 10x squared, if my pen will let me write it today. Typically, once I combine two like terms, I like to cross them out. Now we have negative 2x, and of course, this is raised to the first power, even though it's not expressed. So we're looking for its corresponding like term. We can see that we have x raised to the first power right here. So let's combine 2x and negative 4x to be negative 6x. Let's go ahead and cross those out now. And then we have 9 plus 5, which of course is going to be 14. So this is plus 14. All right, so we did this part of the question. It said sum these two polynomials. We went ahead and did that. And now from the sum of those two, we have to subtract this third polynomial. And when you subtract polynomials, you want to take the one by which you're subtracting and put it in parentheses like this. So it's going to be minus 5x squared minus 2x minus 10. All right, and before you can do this subtraction, you actually have to take this negative and distribute it here, here, and here. So this really becomes this 10x squared minus 6x plus 14. Let's go ahead and distribute this negative. Negative times positive 5x squared is negative 5x squared. Negative times negative 2x, and negative times a negative is a positive, so this is plus 2x. And then negative times negative 10, again, a negative times a negative is a positive, so this is plus 10. And now, all we have to do is go through and combine our like terms. Again, we have 10x squared and negative 5x squared. 10x squared minus 5x squared is going to be 5x squared. Let's go ahead and cross those out now. Then we have negative 6x and 2x, which is going to be negative 4x. Go ahead and cross those out now. And then we have 14 plus 10, which is plus 24. All right, so that is the answer to this one. 5x squared minus 4x plus 24. And as it happens, that is answer choice A. All right, so number 6 says if 5 to the x power equals 625, then what is the value of x? So we have 5 to the x power equaling 625. Well, one approach you could take to solving this one very quickly is to plug in all these values for x and see which one of them makes a true statement. So if we plug in 3, that says we're going to let x equal 3. This becomes 5 to the third. 5 to the third is the same as 5 times 5 times 5. What is 5 times 5 times 5? Well, let's work that out the old-fashioned way here. We have 5 times 5, which is 25, and then 25 times 5. If you can't do that mentally, always do it off to the side, especially on test day. You don't want to make simple mental math mistakes. So we have 25 times 5. 5 times 5 is 25, so bring down a 5 and carry a 2. 5 times 2 is 10, plus 2 is 12, so this is 125. So clearly, x cannot be 3 because it does not make a true statement. All right, let's go ahead and let x equal 4. Again, we know x does not equal 3, so this says 5 to the 4th. This is 5 times 5 times 5 times 5, 4 times. We know 5 times 5 is 25. 25 times 5, as we just saw, is 125. So this becomes 125 times 5. Let's do that off to the side so as not to make any mistakes here. 5 times 5 is 25, carry a 2. 5 times 2 is 10, plus 2 is 12, carry a 1. 5 times 1 is 5, plus 1 is 6. All right, so when we plug in 4 for x, we can see that we have 5 to the 4th, which is 625, and it does make this a true statement. Therefore, we know our answer is B4. All right, so that is that one. Number 7 says if x equals negative 1 and y equals negative 2, then evaluate the expression x to the 4th, y to the 5th. Now, there's a reason I included this problem in this practice test, and that's to test your understanding of multiplying positives and negatives. So in case you're watching this on a mobile device, I'm going to go ahead and copy this one down. We have x to the 4th times y to the 5th and we're told to let x equal -1 and y equal -2. So to solve this one, we of course substitute -1 in for x and -2 for y. So let's go ahead and do that. This becomes -1 to the fourth and -2 to the fifth. Now let's go ahead and work these off to the side. We have -1 to the fourth power, which is the same thing as -1 times -1 times -1 times -1. All right, so I'm going to say this. When you have a negative raised to an even power, such as 2, 4, 6, and 8, you know your result's going to be positive. And let's illustrate why that's the case. -1 times -1. A negative times a negative is a positive. So -1 times -1 is +1. +1 times -1. Positive times a negative is a negative, so that's -1. And then finally, we have -1 times -1. A negative times a negative is a positive. -1 times -1, more specifically, is +1. All right, so we took care of that. We know -1 to the fourth is just +1. Let's go ahead and address this next one. We have -2 to the fifth, which says we have -2 multiplied by itself 5 times. And as I just said, whenever you have a negative raised to an even power, you know your answer is going to be positive. But when you have a negative raised to an odd power, your answer is going to be negative. And let's go ahead and work our way through this. We have -2 times -2. A negative times a negative is a positive. So -2 times -2 is +4. Then we have +4 times -2. A positive times a negative is going to be a negative. More specifically, +4 times -2 is -8. Then we have -8 times -2. A negative times a negative is going to be a positive. -2 times -8 is going to be +16. And then finally, we have +16 times -2. Positive times a negative is going to be a negative. You should know that 16 times 2 is 32. All right, so -2 to the fifth is -32. So this becomes, again, we found -1 to the fourth to be +1. So this is 1 times -2 to the fifth we found to be -32. Positive times a negative is a negative. 1 times -32 is -32. All right, so the answer to this one is B, -32. I included this problem to illustrate that you have to know positives and negatives to be successful on this test. And of course, I do have a video about positives and negatives on my YouTube channel if you need that. All right, so that is that one. All right, so number 8 says if y over 4 minus 2 equals -20, then what does y equal? So in other words, we want to solve this equation such that it looks like this, y equal to something by itself. All right, so let's start by copying this equation down. We have y over 4 minus 2 equals -20. All right, we're trying to solve for y, so the first thing I'm going to do is get rid of this -2 by adding 2 to both sides. This crosses out here, leaving us with y over 4 on this side equals -20 plus 2 is going to be -18. All right, so the only other thing we have to do is get rid of this 4 from the denominator of y. And to do that, we'll just multiply both sides by 4. This will cross out here, leaving you with y on this side. And now we have -18 times 4. Again, on test day, you might be a little bit nervous, so it behooves you to work out things on your scratch paper as much as possible. A negative times a positive is going to be a negative, but now I'm going to work out 18 times 4 off to the side. 8 times 4 is 32, so bring down a 2, carry a 3. 1 times 4 is 4, plus 3 is 7. So this is -72, which we can see is answer choice D in this case. All right, so number 9 says what number comes next in the following sequence? We have 3, 6, 18, and 72. So honestly, there is nothing I can teach you to solve a question like this. Instead, all I can say is you have to find an operation or operations that get you from one term to the next term in the sequence reliably. All right, so in some cases, you're going to have to think about it a little harder than in other cases, but you might start this one by saying to get from 3 to 6, I would multiply by 2. All right, that works. To get from 6 to 18, I can't multiply by 2 because 6 times 2 is 12, but 6 times 3 is 18. All right, so we have times 2 times 3. We might have a pattern developing here. What about to get from 18 to 72? Hopefully I can multiply that by 4, and then we will have, in fact, a pattern here. What is 18 times 4? We've done this one in the video already. 8 times 4 is 32, so bring down a 2, carry a 3. 1 times 4 is 4 plus 3 is 7. All right, so that times 4 did get us to 72. So to go from 72 to the next term in this sequence, or the next number in the sequence, we're going to multiply it by 5. Again, on test day, you may be a little bit nervous. So let's do 72 times 5. 2 times 5 is going to be 10, so bring down a 0, carry a 1. 7 times 5 is 35, plus 1 is 36. All right, so the answer to this one is B, 360. All right, so number 10 says using 22 over 7 to approximate pi, find the area of a circle that has a diameter of 4/5 of a centimeter. Express your answer as a fraction. All right, so for this problem, ultimately we're going to be finding the area of a circle, and that's one of the formulas on my reference sheet, so you have to memorize it before test day. To find the area of a circle, we use the formula area equals pi r squared. Now, right out of the gate, we're hitting a little bit of a problem here. We're given the diameter of this circle, but we need to find its r, our radius, to answer this one. So you also have to know another fact about circles in order to figure this one out. Notably, you have to know that the diameter of a circle is always twice as long as the radius of a circle. Well, in this case, the problem told us its diameter is 4/5. So to figure out its radius, we can use this little formula here. Again, we know d is 4/5, so this becomes 4/5 equals 2r. Again, we just want r, so we can plug it into this formula over here. So let's divide both sides by 2. This crosses out, leaving you with just r on this side. And we've seen something very similar to this in this video already. It's almost as if I write these questions to reinforce concepts. Uh, we have 4/5 divided by 2. Well, we can write 2 as a fraction by placing it over 1. And remember, when we divide fractions, we follow the algorithm keep, change, flip. Well, in this case, we're dividing 4/5 by 2 over 1. So we're going to keep this top fraction the same. So this is going to become 4/5. We're going to change from division to multiplication. Then we're going to flip this second fraction. So instead of being 2 over 1, it's going to be 1 over 2. And now we just multiply straight across since we're just multiplying fractions here. 4 times 1 is 4. 5 times 2 is 10. Of course, if it's helpful, you can simplify this fraction to make your work a little bit easier. 4 and 10 have a common factor of 2. 4 divided by 2 is 2. 10 divided by 2 is 5. So we can see that the radius is going to be 2/5, and I'm going to write it like this. All right, so we know what r is now. So we can go ahead and plug it into our area formula. This is going to become area equals, what were we told to use to approximate pi? We were told to use 22 over 7 to approximate pi. So let's go ahead and plug that in as well. This becomes 22 over 7 times 2/5 squared. We got to take care of this square before we can multiply these two according to the order of operations. So let's take care of this 2/5 squared off to the side. We have 2/5 squared, which is the same thing as this. You can take this square and apply it to each number separately. This becomes 2 squared over 5 squared. Uh, 2 squared is 4. 5 squared, which is 5 times 5, is 25. All right, so we took care of that. This becomes area equals 22 over 7 times 4 over 25. Again, we're just multiplying fractions here. So we're just going to multiply straight across. Again, when you divide fractions, use the algorithm keep, change, flip. When you multiply fractions, you just multiply straight across. So we got 22 times 4 over 7 times 25. Should be able to do both of those mentally, but if it's test day and you're nervous, you can always work them off to the side like this. 22 times 4. 2 times 4 is 8. 2 times 4 is 8, so this becomes 88. And then 7 times 25. I'm running out of space here, so let's move down a little bit. We have 25 times 7. 7 times 5 is going to be 35. Carry a 3. 7 times 2 is 14, plus 3 is 14, 15, 16, 17. So that's 175. So this is 175 in the denominator. And of course, our units were centimeters. And since we found area, it's going to be squared. So this is 88 over 175 centimeters squared, which is D. All right, so number 11 says if 12 is 25% of a number, then what is 75% of that same number? So generally, problems like these tell you exactly what operations you have to perform in order to answer the question. That said, in this case, I want to illustrate this. At some point, you're either going to have to convert 25% and 75% into decimal or fraction form. You should know that the decimal equivalent of 25% is 0.25, and the fraction equivalent of 25% is 1/4. Likewise, you should know that the decimal equivalent of 75% is 0.75, and the fraction equivalent of 75% is 3/4. All right, so in a previous video, I used decimals to work out a problem like this one. And in this case, I'm actually going to use fractions because I think fractions ultimately are a little bit easier to work with. So let's go ahead and get started. Let's work on translating this into an equation. It says if 12 is 25% of a number. So 12, in math, we associate is with equal. So this says 12 equals 25%. I know I'm going to be using the fraction 1/4 in this case of a number. And in math, we typically associate of with multiplication. So this is 1/4 times an unknown number. That number is unknown. So since it's unknown, I'm going to represent it with the letter variable x. So this is 12 equals 1/4 x. Clearly, by solving this equation for x, we'll know what that number is. So we want to get rid of this 1/4 in front of x. To do that, we're going to multiply both sides by the reciprocal of 1/4, notably by 4 over 1. This crosses out here and here, leaving you with just x on this side. Now we have 4 over 1 times 12. Well, what is 4 over 1? That's the same thing as 4 divided by 1, which is just 4. So this is 4 times 12. So you should know that 4 times 12 is 48. So x in this case is 48. If you didn't know 4 times 12 was 48, you could always do it off to the side like this. 12 times 4. 2 times 4 is 8. 4 times 1 is 4. All right, so we know our number is 48. That said, there's a second part to this problem. It says, what is 75% of that same number? So what is 75% are 3/4 of, again, in math, of is typically multiplication. That same number, well, we know that number is 48. So 3/4 times 48. As you can see, we're multiplying a fraction by a whole number, notably 3/4 by 48. One thing you can do is you can write 48 as a fraction by placing it over 1. And instead of doing this math here, you want to try to simplify this as much as possible, because you could say 4 goes into 4 one time, 4 goes into 48. We just saw it over here, 12 times. So this becomes 3 over 1. 3 divided by 1 is 3 times 12 divided by 1. 12 divided by 1 is 12. You should know that 12 times 3 is 36. And if you didn't, you could always work it off to the side. 2 times 3 is 6. 3 times 1 is 3. All right, so the answer to this one is D, 36. All right, so number 12 says if 3, -4, and -5, -2 are 2 points on a line, then what is the slope of that line? So on my reference sheet, I think on the very first page of it, you'll see the formula to find the slope of a line given 2 points, notably m equals y2 minus y1 over x2 minus x1. And at this point, some of you are probably saying, where do I get x1, y1, x2, y2 from? You get those values from your ordered pairs. So in ordered pairs, we always have an x and a y. And since we have two ordered pairs, this is going to be x1, y1, which would make this x2, y2. And with those things identified, all we have to do is plug them into the slope formula and then solve or simplify accordingly. This becomes y2, which is right here, -2, minus y1, which is right there, -4, over x2, it's right there, it's -5, minus x1, which is 3. Let's keep working this out. By the way, -2 minus -4, this minus minus becomes plus. So this is -2 plus 4, which is just going to be 2. Again, you can think of this like 4 minus 2, which would just be 2. And then we have -5 minus 3. -5 minus 3 is going to be -8. All right, you should recognize that 2 and 8 have a common factor of 2, so we can simplify this. 2 divided by 2 is 1. -8 divided by 2 is going to be 4, so this is -1/4, which is answer choice C. So number 13 says, if the legs of a right triangle are 6 and 9 inches, then how long is its hypotenuse? So we're talking about a right triangle here, so it may be helpful to quickly sketch one of those. Again, a right triangle looks like this. We're told that the legs of the right triangle are 6 and 9 inches. We want to know how long its hypotenuse is. Well, in order to figure that out, we're going to make use of the Pythagorean theorem. Pythagorean theorem says this: a squared plus b squared has to equal c squared, where a and b refer to the legs of the right triangle and c refers to the hypotenuse of the right triangle. Well, how do you always identify the hypotenuse? The hypotenuse is always directly across from the right angle, so we know this is our hypotenuse, which means that this is a and this is b. And of course, we know the legs of this right triangle are 6 and 9, so we can call this 6 and this 9. Really doesn't matter if you let a be 9 or a be 6. The math is going to work out the same way. All right, so with those things identified, let's go ahead and start plugging them into the Pythagorean theorem over here. This is a squared, so this becomes 6 squared plus what is b? B is 9, so this is 9 squared equals c squared. 6 squared is 36. 9 squared is 81 equals c squared. Get on test day, you may be a little bit nervous, so if you want to work this off to the side, you can. You have 81 plus 36. 1 plus 6 is 7. 8 plus 3, that's 8, 9, 10, 11. So this is 117 equals c squared. Again, the length of the hypotenuse is just c, not c squared. So we're going to take the square root of both sides here. This will cross out here, leaving you a c on this side. And we can see that c is the square root of 117. And unfortunately, that is not one of our answer choices. So there must be something we can do with the square root of 117 to simplify it. And you should know your times tables for 9. Again, 9 times 10 is 90. 9 times 11 is 99. 9 times 12 would be 108. What is 9 times 13? Most people don't know their times tables past 12 by 12. So what is 13 times 9? Uh, 3 times 9 is 27, so drop down a 7, carry a 2. 9 times 1 is 9 plus 2, 9, 10, 11. So I can write the square root of 117 as this, the square root of uh, 9 times 13, because as you just saw, 9 times 13 is in fact 117. And if you know your properties of radicals, you know you can break this apart even further to be this. The square root of 9 times the square root of 13. What is the square root of 9? Square root of 9 is 3. So this is 3 times the square root of 13. So we know C is 3 square root 13, which is answer choice B. Number 14 says, what is the product of the reciprocals of 1/5, 0.5, and 2 and 1/2? So let's start by finding the reciprocals of each of these. Let's first find the reciprocal of 1/5. Uh, Again, finding the reciprocal just means you're exchanging your numerator with your denominator. So the reciprocal of 1/5 is 5 over 1. Of course, 5 divided by 1 is just 5. So the reciprocal of 1/5 is just 5. Now, you should know that the fraction equivalent of zero point 0.5 is 1/2. All right, and if you don't, I have a video where I discuss how to convert between fractions and decimals, which you may want to check out. So 0.5 is the same thing as 1/2, so we want to find the reciprocal of 1/2, which means we're just going to be exchanging our numerator and denominator here. So the reciprocal of 1/2 is 2 over 1. 2 divided by 1 is 2. All right, this one's a little bit more challenging. We want to find the reciprocal of 2 and 1/2 now. Um, we're first going to have to convert this mixed number into an improper fraction, which means our denominator is going to stay the same as 2, but then we're going to do 2 times 2, which is 4, plus 1, which is 5. So the improper fraction of 2 and 1/2 is 5 over 2. And now we can find the reciprocal of that. Reciprocal of 5 over 2 is 2/5. All right, we want to find the product of these reciprocals. So product means to multiply. In other words, we're going to do 5 times 2 times 2/5. Well, 5 times 2 you should know is 10. So this is 10 times 2/5. Again, we can write 10 as a fraction by placing it over 1. And when you multiply fractions, you're just multiplying straight across. So this becomes 10 times 2, which is 20, over 1 times 5, which is 5. 20 divided by 5 is 4. So the answer to this one is C, 4. All right, so number 15 says, what is the length of the diagonal of a rectangle if the rectangle has a length of 12 inches and a width of 9 inches? So since we know we're working with a rectangle, let's quickly sketch one of those out. All right. And according to the problem, our rectangle here has a length of 12 inches and a width of 9 inches. Well, you should know some properties of rectangles. Notably, this length is equal to this length. So if our rectangle has a length of 12 inches, that means this is 12 and this is 12. And this width is the same as this width. So if this is 9 inches according to the problem, then this is 9 inches according to the problem. And the question is this: what is the length of the diagonal of this rectangle? Well, the diagonal of this rectangle is from here to here. When you draw a diagonal on a rectangle, you end up creating two right triangles. As a matter of fact, I'll go ahead and pull one of those out for you so you can see it better. We know this is 9 and this is 12. Well, we can see that this right here is the length of the diagonal. But what is this called in a right triangle? This is called the hypotenuse, and we know this is C. We saw something in this video that will help us figure this one out. To solve for C, we actually use the Pythagorean Theorem, which is this: a squared plus b squared equals c squared, where A and B are the legs of the right triangle and C is the hypotenuse. So if we figure out the hypotenuse of this right triangle, we'll know the length of the diagonal of our rectangle. So let's go ahead and do that. Again, we know A can be 12 and B can be 9, so let's substitute those in accordingly. This becomes 12 squared plus B is 9, so this is 9 squared equals C squared. What is 12 squared? 12 times 12 is 144. Again, that is on my reference sheet in case you're wondering. 9 squared is 9 times 9, which is 81, equals C squared. If it's test day and you're nervous, you can always do this math off to the side like this. 144 plus 81. 4 plus 1 is 5. 8 plus 4, that's 8, 9, 10, 11, 12. So bring down a 2, carry a 1. 1 plus 1 is 2. So this is 225 equals C squared. Again, we just want C, not C squared, so we're going to take the square root of both sides. This will cross out here, leaving you a C on this side. And you should know that the square root of 225 is 15. Again, that is on my reference sheet. So C in this case is 15. And if C is 15, that means the length of this diagonal is also 15. So the answer to this one is D. All right, so number 16 says, if a square has an area of 100 square inches, then what is its perimeter? All right, so since we're working with the square here, let's go ahead and quickly draw one of those as best we can. You should know some properties of squares, notably all the sides are equal, which is what those bars indicate. All right, so we're told, according to this problem, that our square here has an area of 100 square inches. Well, how do you find the area of a square? To find the area of a square, you always do side times side. Side times side is the same thing as side squared. And in case it's not obvious, side refers to the side length of our square. So this is S, this is S, this is S, and this is S. We know the area of our square is 100 square inches. So in place of A here, we can actually plug in 100. This becomes 100 equals S squared. To figure out how long one of these side lengths is, we'll just go ahead and take the square root of S squared. This will cross out, leaving you with S. Square root of 100 is 10, so we know our square has side lengths of 10. In other words, our square looks like this. This is 10, this is 10, this is 10, and this is 10. The question is this: how do you find the perimeter of a square? That's what we're being asked to do here. To find the perimeter of any quadrilateral, you simply add up all of its sides. So if we start here, we can add up all these side lengths. That would be S plus S plus S plus S. Well, do we know what S is? We absolutely do. We know it's 10, so this becomes 10 plus 10 plus 10 plus 10. This is 10, 20, 30, 40. So the perimeter of a square with an area of 100 square inches is 40 inches, which is answer choice B. All right, so as always, I like to include some bonus questions in each of my videos. Truthfully, I can make a video like this and have 100 questions, and I think that would just be enough to prepare you for the test. That said, let's take a look at this bonus question. It says, what is the area of the shaded section of the figure below? The circles are identical and have a radius of 5 inches. In addition, they are inscribed by a rectangle. Use 3.14 for pi. All right, so we're trying to find the area of the shaded section of this figure. And let's call that this. The area of the shaded is going to be, let's think about this. We're going to have to find the area of this rectangle. So that's going to be area of the rectangle minus the area of one of these circles, which I'm going to call area of circle 1, minus the area of this other circle, which I'm going to call area of circle 2. All right, so in doing this, we'll get the area of the shaded region of this figure. How do you find the area of a rectangle? We've seen that in this video already. It's length times width. And how do you find the area of a circle? That's pi r squared. And both of these are circles, so it's going to be minus pi r squared for both of those areas. Well, we know these two circles are identical, so they're both going to have a radius of 5 according to the problem. That's right here. Both of the circles are identical and have a radius of 5 inches. So we know what r is in this case. So let's go ahead and plug that in. This becomes length times width minus pi. Again, r is 5, so this is 5 squared minus pi. Again, this is r is 5, so this is 5 squared. All right, so we're at a little bit of a crossroads here because we weren't told anything about the length and width of this rectangle. So there must be some way we can figure out what those measurements are. As a matter of fact, there is. We have to use our knowledge of what a radius really is to figure out the length and width of this rectangle. Again, radius is defined as the distance from the edge of the circle to the center point of the circle. So let's say this is the center point. From here to here would be a radius, and we know that would be 5. And from here to here would be another radius, and that would be 5. Clearly, this is the same thing as the width of this rectangle. So our width of this rectangle is 5 plus 5, which is 10. And using the same definition of radius, we can figure out how long this rectangle is, because from here to here is another radius, which is 5. Let's put a center point on this circle. From here to here is another radius, which is 5. From here to here is another radius, which is 5. So the length of this rectangle is 5 plus 5 plus 5 plus 5, which is going to be 20. All right, so now that we know those values, let's go ahead and plug them in. This becomes 20 times 10 minus, let's work this out. This is 5 squared, which is 25. So this is 25 pi minus 25 pi. All right. 20 times 10, you should know, is 200. And this is, what's negative 25 pi minus 25 pi? That's negative 50 pi. All right, so at this point, we have to know that we were told to approximate pi as 3.14. So we're going to go ahead and substitute that in. Now this becomes 200 minus 50 times 3.14. And I'm going to go ahead and work that off to the side now. We have 50 times 3.14. We're multiplying a whole number by a decimal. So the trick here is to clear this decimal by shifting it 2 times to the right, and then rewriting this problem without a decimal. So this will become 314 times 50. And once I work that out, I'm going to take the 2 decimals I shifted to the right here and shift them back into the left. Let's work this out now. 4 times 0 is 0. 1 times 0 is 0. 3 times 0 is 0. Before we start multiplication with this 5, we have to bring in a 0 placeholder. 5 times 4 is 20. Carry a 2. 5 times 1 is 5, plus 2 is going to be 7. And then 5 times 3 is 15. Let's add this all up now. 0 plus 0 is 0. 0 plus 0 is 0. 7 plus 0 is 7. 5 plus nothing is 5. 1 plus nothing is 1. Bring our 2 decimals back in. 1, 2. So this becomes 200 minus 157. And if you can't do that mentally because you're nervous on test day, you can always work it off to the side. We have 200 minus 150. I think my pen's given up on this practice test. 200 minus 157. 0 minus 7 we can't do, so we're going to have to borrow from the left. Can't borrow from 0, so we're going to have to borrow from this 1. This will become 10. Now we can borrow from the left, so this will become 9. This will become 10. 10 minus 7 is 3. 9 minus 5 is 4. 1 minus 1 is nothing. So we can see that this is going to be 43 inches squared. Why is it squared? Because it's the area of this shaded section. Area is always squared. And we can see that that is answer choice A. All right, so that is it for this video. As always, I hope you found it helpful. And as usual, you're more than welcome to leave feedback in the comment section below. So some of you will notice that each week I've been posting a practice test video for both math knowledge and arithmetic reasoning. And here's why. Some of my math knowledge practice test videos include easy questions. Some of them include medium questions. And as you saw today, some of them include hard questions. Before you take the actual ASVAB or PiCAT, you should watch at least 10 of these to really get a feel for the test. Of course, all the practice tests on my YouTube channel are completely free. And as a matter of fact, you'll find all my recent practice tests in my playlist called Math Bootcamp for the ASVAB and PiCAT. If you want to help my channel out, please consider subscribing to it. And on that note, I'm going to go ahead and cut you loose.